Hello everyone, my name is Drew Patel and welcome to Lab 3, which is Magnetic Field of Permanent Dipole Magnets. To begin, the purpose of this lab is to observe and analyze the interaction between magnetometer and bar magnets to understand the behavior of magnetic fields. We'll be using the fundamentals of Biot-Savart law that explains the magnetic fields produced by various objects. Additionally, this lab is being done assuming that there are no magnetic fields interacting with the magnetometer other than the Earth's magnetic field. This is the data I collected during the experiment. I noted the distances at the net magnetic fields of 20, 70, 120, 170, and 220 with 3 trials each. The result noted was then put into the graph to produce a line with an average curve around it. Additionally, I also calculated the off-axis fields to produce the net magnetic field. One possible error during the data collection could be that human error from measurements from the meter stick. Some of the useful formulas would be the 4 fundamental formulas that make up this experiment. Using these formulas, I was able to find the values of n, the k, and mu. At first, treating the graph from the data collection as a line with a slope and intercept, n is considered as the slope and ln of k is considered to be the y-intercept. Using these values and equating the other equations together, you can determine the value of mu, which in this case is 2.405. Some of the observations noted were that when the magnetometer is far from the magnet, the magnetic field in the x direction does equate to 0. When moving closer to the magnetic field does not increase, rather it does not decrease, rather it increases. The position of the magnetometer has tremendous effect on the x-axis, on the x component of the magnetic field. And as I previously mentioned, moving closer to the magnet does increase the magnetic field. This is my GlowScript code. At first, using the formula for the magnetic field, a function is written to run multiple times for different arrows. Along with that, multiple arrows are created to show the magnetic fields with magnitude and direction at different observation locations. An arrow for the perpendicular field at 45 degree was also created for reference. And one major observation could be made that arrows on the axis of the magnet are twice as long as the ones on the perpendicular axis to the magnet. Lastly, the what if questions that say, what if we hadn't compensated for the magnetic north with respect to the Earth's magnetic field? Well, in that case, we'd simply just add the magnetic field due to the Earth using the fundamentals of superposition. And second, what if two identical magnets were stuck end to end? Well, the result would be affected in a scalar manner as they would be scaled up by some amount due to the second magnetic field. Um, that's it. Thank you for listening.